In the last video, we looked at the different laws of exponents. Let's say you have this example. Let's say you have something like 3 times x to the power of minus 2 times y cubed, and then times another x, and all of that over y squared times the square root of x. Okay, well, what's the goal here? The goal is to simplify the expression as much as possible, all right? And x and y are greater than 0. Well, very briefly, you can see that the square root at the bottom can be written as the exponent to the 1/2. So you can rewrite this as, well, you'll have the same thing at the top, but at the bottom, you have y squared and then x to the power of 1/2. Okay, so I'll write the reasons here. So you could say since square root of x equals x to the power of 1/2. All right, and you can also see that you have y on the numerator and a y on the denominator, but the y on the numerator has an exponent it's 3, which is bigger than the exponent on the y in the denominator. Okay, and since you're looking at the quotient of those two, you can just subtract those numerators. So you'll end up with a y at the top only. So you'll end up with 3x exponent minus 2, and then 1y, and then x. Then there's not going to be a y at the bottom. There's just going to be x to the power of 1/2. Okay, and then since y cubed over y squared is equal to y 3 minus 2, and that's going to give you just y to the power of 1, because 3 minus 2 is 1. Okay, well, the next step, that's going to be you looking at the x's. All right, now you have x's at the top and at the bottom, and you can work with the ones at the top first. They're multiplying each other, so that means you're going to add the exponents. You're going to end up with 1x, and with that x, you can subtract the exponent with the x to the exponent of 1/2 in the denominator. You're going to end up with an x either in the numerator or the denominator. So let's see here. You have let's do it on the side here. So since you have x to the power of minus 2 times x, let's just work with the x's, and then x 1/2 at the bottom. Okay, you're going to add the exponents of these two x's. This has a 1. It's usually never written, but there's a 1 there. So you have minus 2 plus 1. That's going to be minus 1. So you have x to the power of minus 1 over x to the power of 1/2. And since you have a quotient, you're going to do the same thing you did up here. You're going to subtract them. All right? And you know what? Let me write it. Let me write it at the bottom. So you're going to have x minus 1 minus 1/2. And you end up with x minus 3/2. Well, since you have a negative exponent, that's going to be the same as the reciprocal. You're going to have 1 over x to the power of 3/2. So you're going to end up with an x only in the denominator. So you have 3y over x to the power of 3/2. I was going to write 1/2, but it's 3/2. All right, you have that. And let me just extend this a bit more briefly. Okay. Now you have a fraction for the exponent, for the x variable in your denominator. Usually you would change that back to the radical symbol. All right. And what you could do here is the following. You could do 3y over. Well, you have two things there, right? So let's write the since phrase. You want to let me move it a bit down. Let's move it down here. Okay, and since well, we have x to the power of 3/2 at the bottom. That's going to be the same as 2x's, right? What are two numbers that can add up to 3/2? Well, you have Well, actually, no. Let's not think of a sum. Let's think of a product. Two numbers that multiply together that make up a product of 3 over 2. Well, you could have 3 on the inside, and on the outside of the bracket, you have 1 over 2, right? Remember this rule from the previous video was that if you have an exponent inside an exponent or a power within a power, then you're just going to multiply the two. We use the opposite logical reasoning of that, I guess you could say, to come up with two numbers. Now you know that 1/2 is exactly the same as the square root, right? So you have the square root of x to the power of 3, and you can write it like so. All right. Now usually, well, not usually, most of the time, you wouldn't write radical symbols in the denominator. You would use something called rationalizing the denominator to get rid of that radical symbol. But for now, we're going to leave the answer as such because the video today was focusing on the different exponent laws that you could use to solve the problem or to simplify the expression. All right. So you used pretty much all of them today. All right. And well, an answer of that's also fine. You could leave it like that, or you could also write it as 3y times x to the power of negative 3 over 2, right? Because that's the opposite of the reciprocal, right? That's right here. You could write that. That's also acceptable, but you wouldn't. Actually, that's not acceptable now that I think about it, because it's preferable to write your full solution without negative exponents, right? But it's the same thing, right? Obviously, this is the same thing. All right, and you can prove this computationally in a simpler way, and yeah, a positive exponent is preferred.